Hello, so today we are going to do this problem called max area of island. So the problem says we have m by n binary matrix grid, and an island is basically the group of ones, and we can go in 4 directions, so left, right, top, bottom, so horizontal or vertical. And you may assume that all 4 edges of the grid are surrounded by water. And then an area of an island is the number of cells that have value 1. Okay, so if we take a look here, these 0 values, this is water, and then these are the islands, ones that are connected in these 4 directions. So what we want to return is the maximum area of an island, so basically the maximum number of connected ones. And if you take a look here at these, 1 here, 4, 5 here, 5 here, and then 6, so the answer is 6. So that's the problem. Now let's see how we can solve it. Okay, so let's see how we can solve it. So here this is very much similar to the different problems about DFS, right, on a graph, or even like just finding connected components. And then what we want is, among all the connected components, what we want is the maximum number of ones. So we want the maximum length of those connected components. So that's essentially what we are interested in here. So what we can do is just go through all these cells, and if a cell is 0, we don't need to worry about it. But if a cell is 1, we want to check its neighbors, right? Keep checking its neighbors. So we go all the way here, we go all the way here, and then count them. So we'll find it's 4. So we'll code this as the max, and then go to the next connected components. It's 1, so it's not the max. Here, we go through all the neighbors, we find that it's 5, we replace it. And we do the same thing here, 5, it's the same, 4, 5 is better. Here we find that it's 6, and so we get the max as 6. So that's essentially what we are going to do here. Now, one thing we need to do is keep track of the visited cells so that we don't go back. Let's say once we visit here, we don't go back either through this or through this cell. So once we visit a cell, we don't want to visit it again. The simplest thing to do is to just replace, once we visit a cell, replace the value 1 with 0. An alternative way of doing it is using a set of visited or seen cells and just adding them. And so before visiting a cell, we check if it's in the visited set, we don't visit it again. So that's essentially the main idea here. We'll do DFS, we'll go through the neighbors, we'll go through each cell if the value is not 0, which means it's not visited yet. Then we visit it and we start a DFS from it, and we keep going as long as we have 1. We keep going through the neighbors and count how many ones we have, and then we record it against the max. We compare it against the max and record it. And once we are done going through all the cells, we return the max. So that's pretty much the idea. Now, as I said, this is just looking for the longest connected components, right, and returning that length. So we can use DFS to do that, but we can also use union find. In this solution, I will do DFS because it's simpler. Yeah, so let's get started. Okay, so let's solve this here. So what we need first is just to record rows and columns, basically the number of rows and number of columns, so that we can iterate through the cells. So that would be length of grid 0. And now we iterate through the different cells, so rows, and then G is going to be for columns. And now if the cell value is not 0, so if it's 1, that means we can start exploring. So it's potentially the largest connected components. The other thing we need is the max count. We need to keep track of that. So max count is 0. And we need to start our DFS. So our function is going to be DFS of I and j. Okay. And then it will return the count. So this returns count of ones, essentially, right? And so what we want to do is basically compare take the max of this and DFS of I and j. Now one thing to note is we are starting from I and j, right? And so we want to count this cell here because we won't count it. Actually, maybe let me show the what DFS function contain before doing this. So if we go here, what we need to do now first, since we visited it, we visited I and j, we need to assign the value 0 so that we don't visit it again. If you want, you could use a visited set, but I'll use this. Now we want to go through the neighbors of this cell, and so the neighbors are both horizontally and vertically, right? So I plus 1j, ij plus 1, and I minus 1j, and ij minus 1. So these are the neighbors. Now we want to go to the neighbor only if first it's within the boundaries, and then second the value is 1, right? And so we will check if it's within the bounds. For I, it's smaller than rows and bigger than 0. For j, bigger than 0 and smaller than columns. And we want to make sure that this neighbor grid is equal to 1. Now if it is, what we want is we want to get the count for ij here. We want to get the count of all of its neighbors that have value 1. So what we'll do is start the count equal to 0. And now we would add, since we found a neighbor that has not been visited yet because its value is 1 and its initial value was 1, we want to add it to the count. So we want 1 for this cell here, and then we'll visit in I and j because maybe there are other neighbors with value 1 next to it. So let's say we are here. Let's say we are here. We want to add that, count that, and then we want to go to the neighbors, right? So that's the idea here. And now we want to return count at the end. Here, as I said, we add 1 for the neighbors. And so for this initial value, we want to add 1 to count it because its value is 1. And then now at the end, we want to return the max count we found so far. So let's run this. Now you notice we don't need to check the boundaries here because we are already doing it here. Okay, so let's run this again. And let's submit. Okay, so that passes test cases. Now, in terms of time complexity, this is of n by m, or rows by columns, because we visit each cell at most once, right? Overall, and so because once we visit it, we set it to 0, so we don't visit it again. So at most we will do the entire grid once. So it's n by m in terms of time complexity. Yeah, so that's pretty much it. Please like and subscribe. It helps the channel a lot. Thanks for watching, and see you on the next one.